Good morning, my pre-calculus students. First off, good job so far turning in your work. A couple of you still need to do the first couple of assignments, but for those of you who have been keeping on top of it, very good. Congratulations, we've graduated onto more difficult problems where you need to solve by factoring. So before we get into the trig portion of it, I want to show it to you algebraically first. Chloe is ready to learn. Are you? So if we had this problem that said 4x squared minus 1 equals 0, and I told you you needed to factor this in order to solve for 0, well, we would use dots factoring because we got difference of two perfect squares, and we'd have 2x plus 1 times 2x minus 1 equals 0. From there, we do our t-chart. We set each of these equal to 0. 2x plus 1 equals 0. 2x minus 1 equals 0. And we get x is equal to negative 1/2 and x is equal to positive 1/2. Okay? That shouldn't be any problem. That is, Algebra 1 stuff. So how do we turn a problem like this into a pre-calculus or, a trig equation problem? Well, what if the problem were 4 sine squared x minus 1 equals 0? If this were the case, then one option you could do is what we did before, is we let y or let x, doesn't matter, any variable you choose, let y equal the sine of x. And remember, when you're squaring sine of x, it's sine squared x. You don't put it at the end because then it looks like you're squaring the angle. So this would become 4y squared minus 1 equals 0. Looks familiar, doesn't it? Yeah, we could solve that the same way that we just did. But I'm just going to show it to you without substituting in, since we just did it with substitution. Well, in this case, you can do dots here, and it will become 2 sine x plus 1 times 2 sine x minus 1. That's still equal to 0. Okay, let me center the camera. And then we could go into our t-chart. And we have 2 sine x plus 1 equals 0. So we have 2 sine x equals negative 1. So therefore the sine of x is equal to negative 1/2. And on this side we get 2 sine x equals 1. So therefore the same way we get the sine of x equals positive 1/2. So from this point forward, it just turns into a problem like we did for the last 2 days. We take each of these individually and we say, okay, the reference angle is going to be 30 degrees. So the reference, that marker is dead. Let's get rid of my red one. Let's see if the orange shows up. So we get the reference, hopefully you can see that, is 30, all right? And since it's negative, we're in which quadrants? Well, sine is positive in 1 and 2, so it's negative in 3 and 4. I'm running out of room. See, I'm working on my daughter's toy here, just so you guys know. Well, quadrants 3 and 4, a reference angle in quadrant 3, we do 180 plus 30, and we get 210. Let's see if I could squeeze it down here. 210. And in the fourth quadrant, we do 360 minus 30, which is 330. So the two angles between 0, sorry, I never said between 0 and 360 degrees. It's always important to look at the domain, see what they're restricted. So the ones that solve the left-hand side, where sine of x is negative 1/2, is 210 and 330. And on this side, well, we've got the same reference angle, but now we're positive. So that means we're in quadrants 1 and 2. So that means it's 30 and, well, what's 180 minus 30? Is 150. So for this particular problem, there are 4 answers. The 4 answers are x is equal to 30, 150, 210, and 330. And that's how you'd solve a problem like this. What about sine of x plus radical 2 equals negative sine of x? Okay. Just like our other ones. Sorry, relax, Chloe. Just like our other ones, okay, I think the best way to do it is substitution. So and I'm going to use y since we already have an x and you don't get confused. Let y equal the sine of x, because then you're turning it into an algebraic problem. So it just becomes y plus radical 2 is equal to negative y. That's what the problem is. That's all this boils down to. Then how would we solve for y? Well, you learned in pre-algebra that you'd have to get all of your y's on the same side. So we'd have to add a y to each side, and we'd have 2y plus radical 2 is equal to 0. Subtract radical 2 from each side. We get 2y is equal to negative radical 2. Divide by 2, y is equal to negative radical 2 over 2. Okay, soak that in for a second. So we just did a little bit of algebra. We substituted y in for the sign of x. So y plus radical 2 is negative y. We got all the y's together. We got the radical 2 on the other side. And then we saw we got y is equal to negative radical 2 over 2. Let me just wipe it to make more space. Okay, so we have y equals negative radical 2 over 2. I know, Chloe. Look, I have the two of them here. Chloe, say hi. Serena, say hi.
Hi.
They want to go together. Hi. Where's Zoe's down there, and Zeus is watching TV with you. You can go back watch TV, sweetheart. I'll be with you in a second. Hold on. All right. Yeah, this is what I'm dealing with. Hold on a second, guys. So we have the sine, since we let y equal the sine of x, we have the sine of x is equal to negative radical 2 over 2. Okay? Now, well, what's our reference angle? You look at your chart, and we have a reference angle of 45 degrees, okay? What quadrants are we in now? Well, sine is negative, so we're in quadrants, what, 3 and 4. Wait, hold on one more second. All right, so since we're in quadrants 3 and 4, we do 180 plus 45, which gives us an angle of 225 degrees. And over here, we do 360 minus 45, which is 315 degrees. I recommend doing it this way. I highly, highly recommend substituting it in, turning it into an algebraic problem. If you're good though, and you don't need to do it, then fine, more power to you. All right, but you have to know all of your methods for factoring. You might have to do trinomial factoring. You might have to do dots, GCF, just something, okay? If you have any questions, please let me know. Take care, guys.